Hi friends, welcome to Devrat Knowledge Villa and you are watching our English video series. We are learning CPU scheduling. In terms of CPU scheduling, today's our topic is limitation of shortest job first. Before this video, we have discussed first come first serve and shortest job first, two algorithm, and today we are discussing the limitation of shortest job first. We will understand limitation of shortest job first by taking two different examples, and we will find the average turnaround time as well as average waiting time for both the example. But one thing I want to clear, if you want to understand the limitation of shortest job first, so please if you are still remain to watch our video regarding to shortest job first algorithm, then please first watch our video of shortest job first. If you want to watch, you will get the link in upper right corner into the I button. You can click the I button and you can watch our video of shortest job first algorithm. Then you will be able to understand the limitation of shortest job first. So let's start calculating average turnaround time and average waiting time. First, look clearly this both the examples. We are here with the three different processes P1, P2 and P3. We are with the two parameters, that is arrival time and burst time. One parameter is same for both the examples, that is burst time, because burst time of process P1 is 10 here, same burst time is 10 here for the example 2 also. For P2 and P3 burst time is 1 time unit, and same for the example 2, P2 and P3 burst time is 1 time unit. Whatever the difference is here, the difference is into the sequence of process arriving in both the cases. Let's see how we will get the difference of this type of arrival time into the result. Let's start calculating, and we will first draw the Gantt chart for our process. So always we are starting our Gantt chart at time unit 0. So first CPU will allocate it to the process P1. Why? One thing is if you have a doubts, like we are following shortest job first algorithm and we have to allocate CPU to the smaller process first, or get processes which process have a smaller burst time. But if you will look here at a time unit 0, no one other process was arrived, only P1 was arrived at time unit 0, so we can't compare burst time of different processes. So we have to compulsory allocate CPU to the process P1. So that's why P1 executing first, and P1 execute for the 10 time units, and P1 complete its execution at a 10 time units. So 10 becomes a completion time for process P1. Now up to the execution of P1, two different processes P2 and P3 arrived at a time unit 1 and time unit 2. But we can't stop P1 for the execution because SJF is working in non-preemptive mode. So first we have to wait for the execution of P1, then we can start P2 and P3. Now if P2 and P3 both arrived, so we have to compare the burst time, but same burst time we are getting, so we can start any one out of them. But logically if we will think P2 was arrived first, so we can start P2 first, or people are generally following the sequence, so we will start P2 first. If you want to start P3 first, then you can start P3 also. So P2 will start its execution and P2 will execute up to the 1 time unit. So P2 will complete its execution at a 10 plus 1, 11. So 11 becomes a completion time for process P2. Next only P3 process remains, so by default P3 will start its execution. P3 will execute for the 1 time unit, so 11 plus 1, P3 will complete its execution at 12 time units. So 12 becomes a completion time for process P3. Now we have a values of completion time, so we are able to find the turnaround time. So we can calculate turnaround time by subtracting arrival time from the completion time. So turnaround time will be the completion time minus arrival time. So 10 minus 0 equal to 10, 11 minus 1 equal to 10, and 12 minus 2 equal to 10. So for all these three processes, turnaround time becomes 10 time units. For the waiting time, we will find waiting time by the equation of turnaround time minus burst time. So 10 minus 10 is equal to 0, 10 minus 1 is equal to 9 and 10 minus 1 is equal to 9. So here we are getting the values of waiting time for all these three processes. Now we will find the average turnaround time and average waiting time. So for finding the average turnaround time, we will make summation of all these three digits 10 plus 10 plus 10, and we will divide this sum by total number of processes. We have a total 3 processes, P1, P2 and P3. So we will divide this total by 3. Total is 30, 30 divided by 3, so you will get 10. So it is again reasoning tip, values are same, so no need to make the total and divide. So keep in your mind this type of tricks. Average waiting time, for the average waiting time we will make total of these three value 0 plus 9 plus 9, and we will divide it with the total number of processes. Total number of processes are 3, so 9 plus 9 18 divided by 3, we will get 6. So here we are getting average turnaround time is 10 time units and average waiting time is 6 time units. We will also find these values for example 2 also. So let calculate for the example 2 also. We are starting our Gantt chart from time unit 0. So we will look at a time unit 0 how much processes arrived. So only P2 arrived at time unit 0. So again no need to compare burst time of another processes. If more than one process was arrived at time unit 0, so we can compare burst time of both the processes and we can start smaller one first. But only P2 arrived, so definitely P2 will start its execution and P2 will execute for its burst time. Burst time for process P2 is equal to 1. So P2 will run up to the 1 time unit. P2 will complete its execution at a time unit 1. So also 1 become completion time for process P2. Now time unit 1, we will look how many other processes arrived. So at a time unit 1 only P3 arrived. P1 is still not arrived, so we can't compare burst time of P1 and P3 because only P3 arrived at time unit 1. So CPU will allocate it to the process P3. P3 will start its execution and P3 will execute for the 1 time unit. So P3 will complete its execution at 1 plus 1, 2. So 2 become completion time for process P3. Now only P1 is remain. So we will check P1 was arrived or not at a time unit 2. Yes, P1 definitely arrived at time unit 2. So P1 can start its execution and P1 will execute for the 10 time units. So P1 will complete its execution at a 2 plus 10 is equal to 12. So 12 become completion time for process P1. Now we can find the turnaround time. Turnaround time is completion time minus arrival time. So 12 minus 2 equal to 10. Now 1 minus 0 equal to 1 and 2 minus 1 equal to 1. So these are the values of turnaround time. After getting turnaround time, we are able to find out waiting time. Waiting time would be turnaround time minus burst time. So 10 minus 10, it will be 0, 1 minus 1, it will be 0. Also here 1 minus 1, it will be 0. Let's find the average. For finding the average turnaround time, we will make sum of these three value 10 plus 1 plus 1, 12, 12 divided by total number of processes 3, 12 divided by 3 is equal to 4. 4 unit is a total average turnaround time. For the waiting time, no need to find the average because all values are 0, so definitely average lead to 0. So here we are writing for the formalities 0 divided by 3 is equal to 0. Now we will compare the average turnaround time and average waiting time for both the examples. So we will able to find out the limitation. So let's see what is the difference between the results of example 1 and example 2. So burst time was same for the all these three processes. Get it? Just difference was there is in arrival time. Here P1 arrived first, here P2 arrived first. But what is the difference? P1 is a larger process, it will require CPU for 10 time units, and P2 is a smaller process. P2 requires CPU for only 1 time unit. So that is the wide difference here. Here larger process arrived first and here smaller process arrived first. So into the result, here average turnaround time is 10 units, here average turnaround time is 4 units. Here average waiting time is 6 units, here average waiting time is 0 time units. So that is the difference in result. And here, due to the longer process arrived first, it will lead to the long waiting time. And here smaller process arrived first, so it will lead to the smaller waiting time. So here waiting time is greater, here waiting time is smaller. So that is the difference, and this thing is known as a limitation of shortest job first algorithm. We are working in non-preemptive mode, so whenever larger process arrived first, so shortest job first algorithm can't stop that process to execute. So remaining process will goes to the long waiting. Here 9 and 9 units for the P2 and P3, it is a waiting. Here for the process P1 waiting is 0. So this thing is known as a limitation of shortest job first, or we can say that it is a convoy effect for shortest job first. Hope you are understanding the video. Thanks for watching Devrat Knowledge Villa.